Okay, I still have this tiny little space down here that I can talk to you and put something in here. And so I'm going to leave this up here. A changing magnetic field produces an electric field, and a changing electric field makes a magnetic field, because now we want to talk about applications of electromagnetism. And so the first application is going to be light itself. So a electromagnetic wave is light, and there are different kinds of light. We're going to talk more about this in a future lesson, but you've got radio waves, visible light, infrared, X-rays, gamma rays. So all of those different kinds of light are an electromagnetic wave. And the reason why we call it an electromagnetic wave is that it has an electric field part that is going to be oscillating with a certain frequency. That frequency is the frequency of that particular kind of light. So radio waves have large wavelengths, but a gamma ray has a very, very small wavelength. So this is the electric field. The magnetic field is always going to be perpendicular to it. So that if the electric field is oscillating up and down, then the magnetic field is going to be oscillating like this. And so that's why they call it an electromagnetic wave. It's partially electro, partially magnetic. You can't separate them. So if you take the electro part out, the light wave falls to pieces. Okay, the second one was the generator and the motor. So this one is very important. This would make for an excellent essay question. Draw a picture of how does an electric motor work, and then explain it in terms of the right-hand rule. Okay, so what you would do is you need to have a magnet. So in that picture there, it's got the north over here and the south is over here. And then you would want to draw the magnetic field in between. So the magnetic field is going this way because you take a teeny tiny north pole and put it in there, and it would be pushed in this direction. So that's the direction of the magnetic field B. Okay, then we take a wire and we put it into that magnet. So I'm going to take a wire, I'm going to put it like this, so it's going into the board and is carrying a current I. So you're going to have a wire that you put into that magnetic field, and it's going to be carrying a current I like this. And then you should know, you're using your right hand rule, you should be able to predict, is that wire going to be pushed up or is it going to be pushed down? Okay, then take the wire and bend it so that it makes a coil. So here's another wire that's coming out of the board, and then use your right hand rule to figure out what that wire is going to do. Put the two effects together, and it's going to cause the coil to twist like this in that magnetic field. And then if you put this thing called a commutator, which we don't care about, but if you put a commutator on it, it will reverse the current and keep it spinning. So notice we put in electrical current and we get out spinning motion. So that's an electric motor. Now on the other hand, if we don't put in electricity, but we manually spin it with a handle, it will generate electricity. And that would be an electrical generator. So be able to explain the electric motor or the electrical generator on the exam. All right, then we have the transformer. So a transformer only works with AC electricity. Voltages need to be at very, very high voltages in the power lines that go to your house. in order to cut down on the amount of heat given off by the wires. Large voltages. We need to reduce the voltage so that it can go into your house. That's what a transformer is going to do. So a transformer is going to be essentially it's a coil of wire. So here's the power line out here. It sends electricity into this coil. This makes a magnetic field. This magnetic field is going to be felt by this coil over here and is going to be turned back into electricity, which then goes into your house. So your house is over here, the power lines are over here for your house. And so only AC works. AC is alternating electricity, and alternating electricity is going to make a changing magnetic field. And then the changing magnetic field is going to produce the current that goes into your house. So there's a formula for it. So my last possible place over here, so I'm going to write over here that the voltage going into a transformer divided by the number of coils going into a transformer has to equal the voltage coming out of the transformer divided by the number of coils coming out of the transformer. So there you go. So that is a formula that you'll need to know for the exam. And so here is a worked out example of how to use that formula. And then this thing on the Maxwell's equations, don't worry about it. It's not going to be on the exam. So there you have it. So as long as you know all of these different terms, and you should know all these units with the exception of the electric field. And if you want to do it for the electric field, then go ahead. But you should know all of this, and then this is all the different formulas that you're going to need to know for the exam. So study really, really hard. Watch all of my videos over and over again until you get nauseous, okay? And I will see you when you come to the test. Bye.